Hello students, welcome to today's session. In today's session, we will learn about how the refraction is taking place through a glass slab. How can we draw the ray diagram? What is lateral displacement? And what are the factors on which lateral displacement depend? Well, since you are investing your precious time, you may ask, sir, what is the scope of this topic from board examination point of view? What are the takeaway bonus points? Definitely, I will discuss those bonus points and expected questions after studying this topic. Now let us go to the topic directly. Refraction through a glass slab and lateral displacement. So for the convenience of saving our time, I have drawn already the diagram on the whiteboard. Please look at the diagram. I will explain it. We can see the glass slab PQRS, a rectangular glass slab, and AO, a ray of light AO, that is called incident ray, falls on the surface PQ, such that NOM is the normal to the point of incidence O at the surface PQ. Now the ray of light AO is ready to enter from air to glass. Refraction is taking place from air to glass at the surface PQ. PQ is the surface of separation between glass and air. So at the surface PQ, the ray of light AO is ready to enter into glass. Since it is traveling from air to glass, it slows down in glass and the ray bends towards the normal. You can see that the refracted ray OB is bending towards the normal. So the ray of light AO suffered refraction at the surface PQ, and on entering into the glass, it is bending towards the normal as per our rule. It slows down. Now it travels through the glass, the same medium in a straight line, and it is incidenting at the point B. Now it is ready to emerge from glass to air at the surface SR. You can see such that N1 B M1 is the normal at the point of incidence at the point B here on the surface SR. Now the ray is OB, the refracted ray is ready to emerge from the glass to air. So you can see that its speed increases and it is bending away from the normal. As per our rule, when a ray of light travels from denser medium to rarer medium, it speeds up and it bends away from the normal. Clear? So BC is the emergent ray here. AO incident ray, OB refracted ray, BC is the emergent ray, such that angle M1BC is called angle of emergence. It's called angle of emergence. Angle AON is called angle of incidence. Angle of incidence, and angle MOB is called angle of refraction. All right? Okay. Now the refraction is taking place at the two parallel sides of a glass slab PQ and SR. All right. So I can say that angle MOB must be equal to angle N1BO. Both these angles being alternate angle and must be equal. Okay. So since these angles are equal, I can say that angle of incidence is equal to angle of emergence here. Angle I is equal to angle E. How can it be equal, angle of incidence and angle of emergence? Because one of the geometrical conditions suggested by Snell's law, when the ray of light is traveling in a straight line, they must be parallel to each other. They must be, of course, because see, the incident ray is in the air, though they have traveled through another medium. When it is emerging out, again it is coming back to the air. All right? Though the incident ray and emergent ray is not following a same straight line path, it is being deviated from its original path. Okay, it has changed from its original path. It's changed its direction from the original path. So both are in the same direction, though they are not following the same straight line path. So I can say that AO and incident ray and emergent ray must be parallel to each other. So angle of incidence must be equal to angle of emergence. So one of the important point you must remember here. So I can write, in case of refraction through a glass slab, angle I must be equal to angle E, such that incident ray AO parallel emergent ray BC. Okay, so that is one of the important geometric condition for the light rays to travel in the same medium. They must be parallel to each other. Okay, so the diagram is clear to you. So this is how the refraction is taking place. Very simple, you just follow the rule, remember the rule and apply here. When a ray of light traveling from air to rarer medium to denser medium, it bends towards the normal. When it travels from denser medium to rarer medium, it bends away from the normal. And the angle of incidence is the angle between incident ray and the normal. And this angle is not the incident ray, angle of incidence. It's called a glance of angle of incidence. Students often get confused between glance of angle of incidence and angle of incidence. Angle of incidence is always measured with respect to the normal and the incident ray. Okay, so don't get confused with the glance of angle of incidence and the real angle of incidence. Okay, yes. Now look at this diagram. In the figure, we observe that refraction is taking place at two parallel sides of a glass slab, PQ and SR. Correct? The angle of emergence must be equal to angle of incidence. That is, incident ray and emergent ray must be parallel to each other. And they are not following the same straight line path. You can see that the emergent ray and the incident ray, though they are in the same direction, they are not following the same straight line path. The emergent ray has shifted its path from its original path. Imagine that there is no glass slab. Imagine that there was no glass slab. What would have happened? The light ray, the incident ray AO would have traveled in a straight line. Since you have introduced a glass slab on the path of light, the medium is changed, the refractive index is changed, the speed has changed, so light has changed its direction from its original path. So I can say that the emergent ray has got displaced from its original path, and that is shown by, I can see that what is the displacement. I have marked it as xy, and this xy is called lateral displacement. It's known as lateral displacement. So what is lateral displacement? Very simple. It's nothing but lateral displacement is a perpendicular shift, the shift of emergent ray from its original path. So that is called lateral displacement. So lateral displacement is the perpendicular shift of the light from its original path. Clear? So I have marked this lateral displacement. So you may ask, what are the factors on which the lateral displacement depends? Because lateral displacement can vary in different situations. So the lateral displacement depends on, I can write, it depends upon, of course, the thickness of the glass block. I can write the thickness of glass block. More the thickness, more will be the, more thickness I write it as T. More the thickness, more will be the lateral displacement X. Okay. Thicker the glass, more will be the lateral displacement. And second factor, the lateral displacement depends on the angle of incidence. It depends on angle of incidence. Remember that the lateral displacement X depends upon the angle of incidence. In which fashion? It depends upon the lateral displacement X is directly proportional to angle I. More the angle of incidence, more will be the lateral displacement, or lateral displacement increases with increase in angle of incidence. And the third factor, the lateral displacement depends on I can write the refractive index of the material medium. The lateral displacement depends on refractive index, mu. What is the letter? Mu of glass. How it will be depending on refractive index. As you know, white light is a bundle of 7 colors, 7 wavelength, starting from violet, starting from violet, indigo, blue, yellow, orange, red, till red, VIBGYO. We know it. Okay. So I can say that since the refractive index increases with decrease in wavelength, so refractive index is inversely proportional to wavelength. I can write. More the wavelength, lesser will be the refractive index. Lesser the wavelength, more the refractive index. So I can say that since refractive index increases with decrease in wavelength, so the lateral displacement increases with decrease in wavelength. So I can write the lateral displacement is inversely proportional to the wavelength. Lateral displacement is inversely proportional to the wavelength. Remember this fact. More the wavelength, lesser will be the lateral displacement. Lesser the wavelength, more will be the lateral displacement. So I can say that lateral displacement is more for violet. Lateral displacement of violet is more than lateral displacement of red. Okay, why? Because red light has maximum wavelength, maximum speed. Red light experiences less refractive index, and violet light being whose wavelength is less and speed is less and experiences maximum refractive index, and violet will be maximum laterally displaced. So remember the point, lateral displacement is more for violet than for the red light. All right. So you might have come across a question, when a glass slab is placed over a word which is written word VIBGYO. Word VIBGYO consisting of 7 letters, such that all the 7 letters are painted in the 7 respective colors. Violet, V is painted in violet, I is painted in indigo, B is painted in blue, and R is painted in red. Alright. So you are keeping this glass block over this letter. VIBGYO, painted in respective colors as per the letters. Alright. Which letter appears to be raised? Which letter appears to be more raised? Which will be closer to you? The answer is so simple. Violet will be raised maximum, because violet, whose wavelength is less, experience more refractive index, and as a result, more the refractive index, more will be the lateral displacement. So it will be violet will be laterally displaced maximum. So violet, the letter V, which is painted in violet color, will be raised maximum, because lateral displacement is maximum for violet than that of red. Is it clear? Okay. So remember the 3 factors on which lateral displacement depends. What is lateral displacement? What are the factors on which lateral displacement depends? It is very important. And this ray diagram is very important for the board examination point of view. You can expect a diagram based questions. An incomplete question will be given, and you will be asked to complete the angle of incidence, angle of refraction, angle of emergence, all right, the incident ray and the emergent ray. Is it clear? So this is how the refraction takes place through a glass slab, and the emergent ray is getting laterally displaced because of change in medium of the glass. All right. So things are clear to you? Fine. Okay. Now let's come to the takeaway board question session. Your bonus rewards. You understood how refraction is taking place through a glass slab? What is incident ray, what is refracted ray, what is emergent ray, which angles are equal, which 2 rays of light are parallel to each other, what is lateral displacement, what are the factors on which lateral displacement depends. Could you understand? I hope all of you could understand the topic. Now let us discuss some board questions based on the topic we studied. You can see one of the board questions in 2010. This is a rectangular glass slab ABCD. PQ is the incident ray. It's an incomplete diagram. You are asked to complete the ray diagram showing the refracted ray, emergent ray. And second part, how are the angle I and E related to each other? So it carries 2 marks. The question has got 2 subparts and it must carry 2 marks. Okay, now ready to complete? Let us go. So this is the incident ray. Q is the point of incidence. Draw a normal. Drop a normal, very simple. And angle between the normal and the incident ray, I mark it as angle of incidence. Now ray of light is ready to enter from air to glass, rarer to denser medium. This can be air, this can be glass. Okay. It must, when it travel from air to glass, it must bend towards the normal. Okay. We bend it. And this angle, I call it as angle of refraction. PQR is the refracted ray. Alright, now draw a normal to the point of incidence here at the surface DC. Now the ray of light QR, refracted ray, is ready to emerge from the denser medium to the rarer medium. How it will travel? Of course it will bend away from the normal. Bending away from the normal. RS is the emergent ray, and this angle is the emergent angle of emergence. Alright, if there was no glass slab, it would have traveled in a straight line. Alright, yes. Now we have completed the diagram. We marked angle of incidence, so angle of emergence, incident ray, refracted ray and emergent ray. Diagram is complete. Alright, and this angle also should be equal to R. Alternate angles being equal. Okay, so that first part is over. What is the second part? How are the angle I and E related? As I have discussed, angle I must be equal to angle E because incident ray and emergent ray is always parallel to each other since they are traveling in the same medium, air and air. Though medium is coming in between. After traveling through and they are emerging out and they must be traveling in air. Alright. So angle I, second part, angle I and angle E must be equal since incident ray and emergent ray are parallel to each other. Okay, so you got easily 2 marks. Once you understand the concept, you can attempt the questions very easily. If you analyze previous year's board questions very closely, you can notice that the topic remains same. The questions are repeated in many ways, in many forms. So in the topic of refraction through a glass slab, this type of diagram based question is sure shot. It is 100% you can expect this type of questions. Let us see another question. The same topic, the question is repeated, the question is being asked in different ways. A ray of monochromatic light is incident from air to glass slab. Draw a labeled ray diagram to show the change in the path of ray till it emerges from the glass slab. Second part, name the 2 rays that are parallel to each other. Third part, mark the lateral displacement in your diagram. So here 3 questions. So it must be carrying 3 marks. Topic remains same. The pattern of the style of question is changed a bit. That's all. So you can draw a label diagram showing the change in the path of ray of light till emerges through the glass slab. So this is the incident ray. It is getting refracted, bending towards the normal, and now ready to go out. And the emergent ray, it is going out. Since it is traveling from glass to air, it is bending away from the normal. Alright, so this is the diagram completed. Angle of incidence, angle of refraction, angle of emergence. This angle again, angle of incidence in the denser medium. Both angles being equal. And if there was no glass slab, light ray would have traveled in a straight line path shown by the dotted lines. And the distance between the original path and the shifted path is, we call it as the perpendicular shift, that is called as the lateral displacement. So lateral displacement x. So I have completed the diagram. I hope all of you understood the diagram, ray diagram. Ray diagram part is complete. Name the two rays that are parallel to each other. Of course, the incident ray and emergent ray are parallel to each other. Which rays are parallel to each other in refraction through a glass slab? Incident ray and emergent ray. I can write PQ parallel RS. Okay. Yes, that is second part. First part is the diagram is complete. Now the third part of the question, same question. Mark the lateral displacement in your diagram. So lateral displacement, as I have marked on the diagram, I write it lateral displacement X. You have marked on the diagram. Alright. So this is the important questions. The takeaway bonus points. Study the topic and take away the bonus points or the board questions. Alright. Thank you for watching.